The key thing here is knowing what the values of sine 45, tan 45, and tan 60 are. Now, back in primary school, you have to remember your times tables. They're not actually really asking you a lot here. You only got to remember a few different values of sine and tan. When I try to recall these, I usually try to think what it looked like on a graph. So sine, that does something like this, and cosine does the other way, so it does that. We're not concerned about cosine, we're only concerned about sine here. So if we wanted to work out sine 45, then, okay, that value there, that's not particularly that nice to work out, but it's where both the cosine and the sine graphs meet. And that value is root 2 over 2. So I have two lots of root 2 over 2. You could simplify as you go along if you wish, and we've got 2 times by something over 2. That's just going to simplify down to root 2. If in doubt of how to do it with surds, think about how you do it with algebra. So if we had x divided by 2 and then we times that by 2, then yes, these are going to cancel out. So that actually works exactly the same. We can just substitute that x back for root 2, and that's what happened. Now tan 45. Tan is essentially the sine value divided by the cosine value. So if we have sine 45 and cosine 45, those are both root 2 over 2. And anything divided by itself is 1, apart from 0. This has some real weird implications. Let's not go into that now. And now tan 60, this is basically sine 60, which is root 3 over 2. It's greater than root 2 over 2, so that's root 3 over 2. And we're dividing that by the cosine of 60, which is a half. And when we're dividing by a half, that's essentially timesing by 2. If I do root 3 over 2 and we times this by 2, we've got the same thing again. We're just going to get root 3. Okay, so we're nearly there. We've got this form up here we need to aim towards. And we see that we need to get an integer value on the denominator. Let's rationalise the denominator. Now, rationalising the denominator, I want to get rid of this root 3. Now, I want to think, what can I times root 3 by to get rid of a surd? Now, if I times it by any whole number, that's not going to help. If I times it by any other kind of number, it's really not going to help. But the simplest way to think about this is how you can undo the square root. The opposite of square root is square. So if I times this by root 3, then that's going to undo the root 3. But I also have to times this bit up here by root 3. Root 3 over root 3 is 1, so I'm not changing the value of this, I'm just timesing it by 1. So root 3 times root 3 gives me 3. And then I have root 2 times by this, then minus 1 times by this. Root 2 times root 3, that gives us root 6. So this is one of our laws of surds, that if I have root of something times by the root of something else, then I basically times both of those together. So that gives me root 6. Minus 1 times this, that's minus root 3. Now let's see if we're in the form which we need to be up here. Yes, we are, because we've got a root of an integer, which is 6, minus the root of another integer, which is 3, and it's over 3. So we've answered the question. This is our answer. It's best to put it on the answer line just to make it clear that that's what's going on, but if the examiner does see it somewhere within your working out and that's your answer, then that's fine, just leave it there.